next concept, Laplace transform of integrals. Means if f of t contains in the form of integration, then what is the technique? Then this is the statement. If Laplace transform of f of t equal to f bar of s. If you know this quantity, then Laplace transform of integral 0 to t f of t dt equal to, the answer is 1 by s f bar of s. 1 by s f bar of s. This is the formula. Then when should I apply this concept? Means Laplace transform of limits should be 0 to t and the function in terms of t, and then the answer is 1 by s into f bar of s. Nothing is there. Just you calculate the Laplace transform of f of t, then divided by s, integration, if it is in terms of integration. Then let me solve some problems. Find Laplace transform of integral 0 to t e power minus t cos t dt. Observe this one. The limits are integration 0 to t, means we can apply the concept Laplace transform of integrals. Then according to that formula, let f of t equal to e power minus t cos t. Then Laplace transform of f of t equal to Laplace transform of e power minus t cos t. Again inside is e power minus t cos t is available. According to first shifting theorem, just you calculate Laplace transform of cos t, then in place of s you have to substitute s by s plus 1. That's why I am writing here s changes to s plus 1. The answer Laplace transform of cos t is s by s square plus 1. Again s changes to s plus 1, means s plus 1 by s plus 1 whole square plus 1. What I am doing here, in s I am writing s plus 1. Wherever s is there, simply I am writing s plus 1, means replace s by s plus 1. On simplification, s plus 1 by s square plus 2s plus 2. This is f bar of s. Once you got f bar of s, then you can apply Laplace transform of integrals, because the integration is available, that's why integration. Using the theorem of Laplace transform of integral, we have Laplace transform of integral 0 to t f of t dt equal to 1 by s into f bar of s. Already f bar of s I calculated. Laplace transform of integral 0 to t e power minus t cos t dt equal to 1 by s into s plus 1 by s square plus 2s plus 2. The on simplification, s plus 1 by s into s square plus 2s plus 2. This is the answer. It's like this we can apply the Laplace transform of integrals. And let me consider another problem. Now observe this one. This problem is important actually. Find Laplace transform of integral 0 to t 2 times integration available. Then cos hat dt one more time, for one more integration dt. That's why we got dt. Now here f of t equal to cos hat, Laplace transform of f of t equal to Laplace transform of cos hat according to basic formula s by s square minus a square. This is f bar of s. Now using the first shifting theorem on Laplace transform of integral, Laplace transform of integral 0 to t cos hat dt is 1 by s f bar of s, means 1 by s by s square minus a square. Then the answer is 1 by s square minus a square. Again applying the Laplace transform of integral 0 to t cos hat dt, means one time integration already I calculated. The answer is 1 by s square minus a square. Again 1 by s, means 1 by s divided by s square minus a square. This is the final answer. Means if you got 3 times integration, then 1 by s cube, like that. This is the general formula. And one more thing, in that problem, the statement I have not explained here. The previously, in Laplace transform of integral 0 to t n times integral 0 to t f of t dt dt so on dt n times. The answer is 1 by s power n into f bar of s. This is the formula. In the previously I have not given in Laplace transform of integrals, I marked here.